All right, let's jump back to a topic that we talked about a couple weeks ago, which is finding tangents to a curve at a specific point. Now before, what we did was we found two different points on the line, we figured out the y values. After we figured out the y values, we figured out the slope, the gradient. Once we knew the gradient and the point, we were then able to use the point gradient form. Sometimes in the US they call it point slope form. And then go through and figure out the line, and it took a while. Well, let's try doing it now, taking a derivative of this function, because if we take the derivative of the function, it will give us an equation that if we plug in, let's say x is 2, it'll tell us the slope when x is 2, the gradient when x is 2, okay? So when we take the derivative, so we get f prime of x, okay? Well, we take our exponent and move it down, so that gives me 3x squared minus 4. Now there's 1 up there. 1 times 4 is 4, but now there's a 0. X to the 0 power is just 1. 4 times 1, still just 4. And then the 2 technically has an x to the 0 power. 0 times 2 is 0, so 0 times x to the negative 1 power is 0, thus it's nothing. This is the equation to find the slope at any point on this curve right here. So let's plug in x equals 2. Okay. So I've got 3 times 2 squared minus 4. 3 times 4 is 12. 12 minus 4 is 8. Okay. So our slope, our gradient at this point right here is 8. So if I'm using the point gradient form, that would give me y minus, this is the point, let's plug in 2, that gives me 2 cubed minus 4 times 2 plus 2, so that's 8, so that'd be negative 6, this would be 8, so 8 minus 8 is 0, plus 2 gives me 2. This is the point 2, 2. So y minus 2 equals 8 x minus 2. Okay. That is the equation. If they asked for it in gradient intercept form, you'd have to go through and solve for y. So if we do that, distribute the 8, that gives me y minus 2 equals 8x minus 16. Add 2 to both sides. Gives me y equals 8x minus 14. So if we drew that line, it would come up kind of like this. It would keep coming down. It would intersect the y-axis at negative 14. Okay? There we go. All right, let's try this problem now. So x is negative 2. So right here, what is the line that is tangent to that curve? Okay? Well, there's two things we need to know. Well, there's a lot of things we need to know. The formula y minus y1 equals m x minus x1. We need to know a point, and we need to know our gradient. So we've got a point. This is the point, negative 2, comma, it looks like it's about negative 2. I'm not quite sure. If I take the x value, negative 2, and plug it in, I do get negative 2 as an answer. Okay? So negative 2 is my point. So the equation here would be y plus 2 equals whatever m is, x plus 2. I need to now figure out what my gradient is, my slope. To do that, I take the derivative. Now remember, with y, the notation is a little bit different. That's going to give me dy equals 2x plus 2 dx. Okay? We took the derivative in respect to y, we took the derivative in respect to x. That's what we did there. So we take negative 2, we plug it in. 2 times negative 2 plus 2 gives me negative 4 plus 2 is negative 2. Okay? That would be my slope from this case. Now here's just a fun problem. If we kept following this line down, where would it eventually intersect the y-axis? Well, let's solve for y. Distribute your negative 2. Y plus 2 equals negative 2x minus 4, minus 2 from both sides. Y equals negative 2x minus 6. So this would technically cross at -6. So there's 1, 2, 3, 4, 5, 6. Right where it would cross, right there. All right, I want you to give this one a try on your own. I want you to find the tangent line for this equation. Okay, so right here, where is the tangent line going to be? Okay, what is the tangent line going to be? For x equals 1, where this is the equation. So negative 2x to the fourth plus 2x cubed minus 2x. Pause the video if you need to. Bonus points if you can figure out where that tangent line intersects the y-axis. Where does that go? All right, you should have paused it. You should have the answer by now. Let's go over how to do this. So the equation that we're going to use is y minus y1 equals mx minus x1, okay? M is my gradient or my slope. So we take our line, we know all these cool things. We know that this is the x value 1, so we've got x minus 1. However, we are not 100% sure what the y value is. So I'm going to take that 1, I'm going to plug it in here. So negative 2 times 1 plus 2 times 1 minus 2 times 1. Well, negative 2 plus 2 is nothing. Minus 2, that gives me a y value of negative 2. So y plus 2. I have to now find my gradient. To do this, I need to take the derivative. Okay? It looks like it's in reference to y, it's not f of x. We're not going to find f prime of x. The derivative of y is dy. The derivative of x is dx. So we need to go through and take the derivative of it all. That gives us negative 8x cubed plus 6x squared minus 2 dx. Okay? All right, if I'm going to figure out the tangent line, I have to take 1 and plug it in. That's going to give me negative 8 times 1 plus 6 times 1. Technically it's cubed and squared minus 2. But they end up just canceling out. Okay, so negative 8 minus 2 is negative 10. Plus 6, that leaves me with negative 4. That is my slope, my gradient for this problem. Okay. If you got that answer, yay, good job. If you didn't get that answer, look at what I did. What did you do different? Might have just been a really simple mistake. Maybe it was you were off by a number or something. Now, I told you there's a bonus point. Can you figure out where this equation intersects the y-axis? It looks like if we're tracing it back up, it should intersect somewhere right around 2. We might be off by a little bit. Let's find out. We distribute the negative 4. It gives me y plus 2 equals negative 4x plus 4 minus 2 from both sides. Y equals negative 4x plus